Hello everyone and welcome to an episode of Interstigation. In today's episode of Interstigation, we'll go over 2021 AIME 2 number 5. So, finally going back to our AIME grind. I might regret this because AIME problems do get a little bit tricky at the end, but we'll try our best to pull through this journey all together. And today we'll tackle one of the easier side AIME, but well, it's still challenging than most of AMC problems, which means that we can go over and look at it together. So it says, for positive real numbers S, let tau of S denote the set of all obtuse triangles that have the area S and two sides with side length 4 and 10. We don't know the third side. The set of all S with tau of S non-empty, but all triangles in here are congruent. So when it means congruent, basically says there is just one unique such triangle. And we want to find the interval of S where that exists. Well, let's think about it. There has to be an angle between 4 and 10, don't we? So in this angle, let's consider the case where, this angle is, acute. If this angle is acute, then some angle other than this may be obtuse. For example, we might have a situation like this. This looks like 4 and this looks like 10, and this is an obtuse triangle. We could also have that there is the obtuse angle over here, and it goes like 4, 10, and another side, we'll just take x as a variable. Now, notice that 10 cannot have, let's think, if 10 has the obtuse angle corresponding to the 4, then this 4 must be bigger than both of these sides. We can see that from the law of sines, where 4 over sine of alpha, let's just name this alpha, is equal to the other sides, let's name them x and y, x over sine of beta. Well, beta is the angle correspond or opposite to it, y over sine of gamma, which means that 4 has to be the longest side over here, but we already know that there is a side 10, so that cannot happen. So in order for us to avoid the unique or non-empty, these are the two sets that we need to take a look at. Now, if we have 4, 10, they definitely have an angle that they are kind of inscribing. Let's take this angle to be theta, or alpha, I mean. If I have one side opposite to it, then the area of the triangle S is equal to 1/2 A times B times sine C, in this case sine alpha, which gives us, we don't need to calculate, but it's sine alpha. And in which case does sine alpha equal? Because we need the same S for them to not be unique. Well, sine alpha is equal to sine 180 degrees minus alpha. I'm using 180 degrees instead of pi, but you can use pi. But because this is just a standard geometric problem, I will use 180 degrees. Well, we can take a look at the standard sine curve, and that looks like this from 0 to 180 degrees. And the only case where two of them intersect with the same y value, you should say, is alpha and 180 degrees minus alpha, which means that is the only case. So if we have this, we could also have, we can draw, let's move this a little bit. we could draw another triangle with another side of 4 and connect, actually. We'll use a more extreme angle of alpha. So let's say we have 4 over here. Let's say 10 over here. And this is the triangle we have. This is the alpha. This is the obtuse triangle that we have. But we could also have, well, the case with 1 minus alpha. We extend this 10 side and say there's an alpha over here. Then if this is 4, then connecting these two, we will get by 1/2 AB sine C that these two triangles would have the same area. And how do we avoid that? Well, one case is that, well, if we have angle alpha less than 90 degrees, then there's always going to be an alpha greater than 90 degrees. That is guaranteed. So we need to make sure that such alpha less than 90 degrees does not exist when the area is greater than something. And also if the angle is less than 90 degrees, well, it cannot stretch too far as to, well, it doesn't have any more triangles to work with. So we have 20 sine alpha. When is alpha the largest? Well, that's when sine alpha is equal to 1 or alpha is equal to 90 degrees. And in that case, we would have 4, 10. There is a right angle over here. We could calculate the area of this is 1/2 times 4 times 10, which it gives us 20. And that is the case where that is the biggest area of all of the triangles that you could make out of these. And there is no obtuse triangle over here. If you lessen the area a little bit, let's say lessen it to 19.9, then there will be a triangle looking some sort of like this, a little bit greater than 90 degrees for us to say that this, well, the area A2 might be, let's say, 19.9. Now, how do we make it so that there is only one possibility? Well, let's think about the case where if we go back towards it. Well, the set the set tau only contains the triangle if the other one is obtuse. So what if the other one we have to make is acute triangle? So if we have, let's say, 4, 10, and something else, let's just make it a little bit better. Something else, this is the angle alpha that we're interested in. And, well, if all of these are, well, acute angles, then we would have an acute triangle, and that does not count in tau. And the only unique triangle that is obtuse in this case would be extending this, and we get the triangle looking like this, which means that we need to somehow find a way to bound the smaller side. Now, let's think about it. Well, if all of these are acute, then what would happen? Which would have, well, the largest angle? And right now, we're considering alpha to be less than 90 degrees. This is the case where alpha is less than 90 degrees. If alpha is greater than 90 degrees, that is always going to create an obtuse triangle as long as, well, it is within 180 degrees, of course. That is always going to create an obtuse one. So alpha is less than 90 degrees right now, and for these two be less than 90 degrees. Which of these two are the bigger angle? Well, it's the angle that corresponds to the 10 by law of sines. Because this angle, let's say this angle is beta, and this angle is gamma. Similarly, we will have 10 over sine beta is equal to 4 over sine gamma. Obviously, sine beta is going to be larger, which means that both of them are less than 90 degrees. So sine beta, beta will be the larger angle. So beta is greater than gamma, and the only case to bound all of them to be equal, the edge case would be beta as 90 degrees. And in this case, the alpha greater than 90 degrees would yield exactly one outcome. So it would make sense that it will be a close bracket over here as shown. Which means that we would have for a right angle and 10, use the Pythagorean theorem, we have square root of 100 minus 16, which is the square root of 84. I know I can simplify this, but there's really no need to. So square root of 84, we find the area, which is 1/2 times 4, square root of 84, is equal to 2 times the square root of 84. And by now we have found the two edge cases that we're looking for. And the interval that we're looking for is simply 2 square root of 84, comma 20. Well, just to clarify that the right-hand side is a parentheses because we would have just one right triangle possible to make, and that it does not count as an obtuse triangle. So that is a parentheses, not a bracket. So 2 to the square root of 84 squared plus 20 squared, we would have 4 times 84 plus 400, or we would have, that's 336 plus 400, give us 736 as our final answer. And that will be it. Thank you for watching this episode of Interstigation. I'll catch you in the next one. Peace out. Go over number 6 as usual next time. So if you are still here in this video, good job, and we'll hopefully catch you in the next one. Goodbye.